have explained that not every element forms ion during the reaction. In fact, only 12 form ions, which 12 elements are there, which easily forms ions. Okay. For example, lithium, beryllium, sodium, magnesium, and all these others, right? So let me tell you about the naming. Hydrogen and the metals, they lose electron, they form positive ions, right? When these elements, they lose electrons, so they form positive ions because electrons are negatively charged. Okay, so when they lose electrons, they are itself becoming positively charged. Okay, so these ions have the same names as the atoms. For example, lithium. It is known as what? Lithium, right?
Yes.
And this one, lithium plus lithium ion, it is also known as lithium. No change in the naming, right?
Yes.
In case of sodium, the symbol of sodium is this. So if I write this name, it is sodium. But if I write the name of its ion, then also it's sodium, right? No change in the name.
Yeah.
So these are about the metals. Lithium and sodium, they are metals, right? But non-metals, they form negative ions, okay, with names ending in IDE. Example, let us see the example. What is it called? F. Which element is it? Tell me, looking at your periodic table, which element is this F?
Which are I pointing at?
This one, this.
At the bottom. Okay. Okay.
Yeah. So what is the name of this element?
Let me check.
Please sit with your periodic table in the chemistry class.
Fluorine.
Yes, very good. It is fluorine. But if I write it as a negative ion, then it is not fluorine. Now it becomes fluoride. So I think second point is now clear that fluorine is a non-metal. It forms negative ions, F minus, and its name is ending with IDE, fluoride. Okay, let us take one more example of this. What is the name of this element? This one? O.
Oxygen.
Yes, it is oxygen. Is it a metal or non-metal?
Non-metal. It's a gas.
Yes, it's a non-metal. So if you write in the form of ion, O2 minus, because you know the valency of oxygen is 2, right? If you write O2 minus, then is it oxygen or oxide? Read the second point. Second point says that non-metals form negative ions with
name ending.
Yes. So this is a non-metal, as you said that oxygen is a non-metal. It is forming a negative ion 2 minus. So its name should be oxygen or oxide.
Yes.
It should be oxide, right?
Yes.
Yes. So I think these 2 points are clear with the examples. Third point says the elements in group 4 and 5, they do not usually form ions because their atoms would have to gain or lose several electrons, so which require large amount of energy. So it is not very easy to gain or lose electrons. For example, see here, elements of group 4 and 5, right? For example, here we have carbon, here we have nitrogen. So what is the atomic number of nitrogen?
7.
Yes. And tell me the electronic configuration.
2,5.
Yes. So it requires either it have to lose 5 electrons to achieve stability, or it should gain 3 electrons to achieve stability. So a larger amount of electrons are required to lose or to gain. It requires a larger amount of energy, say, so they do not form ions easily. They do form, but they do not form ions so easily. Okay, that's why it is written in the third point that the elements in group 4 and 5 they do not usually form ions because their atoms would have to gain or lose several electrons, which takes too much amount of energy. Now, fourth point says that group 0 elements. Group 0 elements are, give me an example.
Um, Iron.
Hmm?
Iron.
What are the name of an element of group 0? This group. This group 0. Check in your periodic table.
Group 0. Like
The right hand side. Look at in the right hand side.
lantern.
In the corner of your periodic table in the right hand side.
I don't. Mine are at the bottom.
Can you see helium there? Helium, neon. These are my group
Oh,
0 elements.
in the group 8.
Yes, it is also known as group 2. Sorry, it is also known as group 8 and also known as group 0. One and the same thing. Okay.
Okay.
So
Yeah.
helium, neon, argon, they are already stable. They have 8 electrons in their outermost shell already. So they do not form ions because their atoms already have stable outer shell. So why do they need to gain or lose electron? Let us see an example of neon. Tell me the atomic number of neon.
10.
Electronic configuration.
2,8.
Yes. So it already have 8 electrons in their in its outermost shell. So why it gains or lose electrons? It is already stable. So it is written that group 0 elements it do not form ions. You have seen neon, but you haven't seen neon plus or neon minus. These are incorrect. Wrong. Because they are already stable, they do not form any ions. Are all the 4 points clear?
Yes.
Okay, so please write it down.
Okay.
You may turn on your camera so that I can see that you are writing.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done.
Now, let us learn the names and the formulae of ionic compounds. For example, if we have a compound in which we have K plus ion and F minus ion, what should be the name of this compound? So as I told you that this is your cation, this is positive ion, this is a metal. Its name remains as it is. It is potassium, so it remains as it is. Now this is a negative ion, which is a non-metal. In the non-metal and the negative ion, we will replace its end with IDE, so it becomes potassium fluoride. Similarly, here calcium 2 plus, it is a metal, it forms positive ions, its name remains calcium only. But since sulfur is a non-metal, it forms negative ions, so its name, it should be sulfide. We have replaced sulfur to sulfide while writing the names of these ionic compounds. Is it clear that KF is known as potassium fluoride and this is known as calcium sulfide? Any doubt is how to write the name of compound?
No, it's the same thing, but
Yes. For positive ion, it is same. The name is same. For example, potassium is same, calcium is same. But for negative ions, we have replaced the name of element, okay, with ending it with ide, IDE. We have replaced fluorine with fluoride. We have replaced sulfur with sulfide. Right?
yes.
Write it down.
Okay, I'm done.
This is another example of how to write the name of ionic compound. Okay, so if it is LIF, then what is its name? The positive part, lithium, it remains as it is. It is lithium. Okay, and the negative ion is F minus. So it is what? Tell me. F minus should be,
Fluoride.
yes, so its name is lithium fluoride. Similarly here, if it is Na2S, then it is positive part, it is metal, it is negative part, it is non-metal. So positive part, it remains as it is, sodium. But here we do not write sulfur because it is a non-metal and it forms negative ion. So we write sodium sulfide. Right?
Yes.
If we see the overall charge on this compound, so it is 0. Why? Because we have two Na plus ions, one Na plus, two Na plus, and we have one sulfur whose charge is 2 minus. So 2 plus and 2 minus cancel out each other, so the overall charge is 0. So write it down if it is clear.
They don't know. Don't you worry. At least give me a blanket to go.
So there are some transition elements which form only one type of ion. For example, silver, it forms only Ag plus ions, and zinc, it forms only Zn2 plus ions. But most transition elements, they can form more than one type of ion. For example, copper and iron, they can form copper plus 1 also, copper plus 2 also. Iron, it can form Fe plus 2 also, and it can form Fe plus 3. So these are my transition elements. Transition elements are the metals which lie in the middle of your periodic table. If you have your periodic table, then you can see you have scandium. See in your periodic table, scandium, vanadium, titanium. These are my all transition elements. Zinc, iron, copper. Okay, all these are transition elements. They lie in the middle of periodic table. So some of them can form only one type of oxidation state, one type of ion. For example, silver, it forms only silver plus 1. Zinc, it forms only zinc plus 2. But similarly, most transition elements, they can form more than one type of ion. For example, copper, it can form copper plus 1, it can form copper plus 2, iron, it can form iron plus 2 and iron plus 3 also. We will see the examples in the next slide. Okay, so you want to write it or have you taken the screenshot?
I could write it.
Any doubt in this slide?
No, ma'am. Done.
Okay. The examples of copper plus 1 and copper plus 2, iron plus 2 and iron plus 3 is these ions. Copper oxide, Cu2O, where copper exists in plus 1 oxidation state. This is this number which is written in the Roman numeral. This is the oxidation state, or you can say the valency also. Copper oxide, CuO, here copper exists in plus 2 oxidation state. Iron chloride, FeCl2, this is name is same. It is also iron chloride. It is also iron chloride. But in this case, iron exists in plus 2 oxidation state, plus 2 valency, and in this, iron exists in plus 3 oxidation state. How? Because we know that in FeCl3, what is the valency of chlorine? I told you in the last class, what is the valency of chlorine?
17.
Configuration. Tell me the electronic configuration.
2,8, 7.
Yes. What is the definition of valency? Check it in your notes and tell me. What is valency?
I'm checking.
And please learn these notes side by side also.
Okay. It's the combining power of an element.
This is the definition on the Google, combining capacity of an element. But I told you that valency is the number of electrons lost
in the outer shell.
No. Yeah, you can say, or you can say number of electrons lost, gained, or shared, not in the outermost shell. Because in oxygen, if you write the electronic configuration, it would be 2,6. So its valency is not 6. Its valency is, oxygen valency is 2. Number of electrons it should gain to achieve stability. So correct definition which I have told you is this only. The number of electrons gained, lost, or shared to achieve the stability. Now tell me what should be the valency of chlorine?
Number of electrons
Gained, lost, or shared? Yeah, so how many electrons does chlorine need to become stable?
1.
Yes, so what should be its valency?
Two, 8, 8.
It needs 1 electron to achieve stability, so its valency is 1. 1. Okay, so here we have 3 chlorine atoms, right? So it is 3 and the valency which is -1 because it gains 1 electron, negative charge. So if this is -3, then this iron it should be +3 because overall it is neutral. Overall there is no charge on this compound. So that's why it is written as Fe plus 3I. Okay, so write down all the examples of compounds of copper plus 1, plus 2, Fe plus 2, and Fe plus 3 with their valencies. Are you writing?
Yes.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done.
These are my two oxides of copper. This is also copper oxide and this is also copper oxide. The only difference is in its oxidation state or valence. It is here second, but it is here first. So you can see that by changing the oxidation state only, this is a black colored compound, copper 2 oxide, and this is a brown colored compound, copper 1 oxide. Okay, so next topic is what are compound ions? We know what are ions, right? Ions are atoms with charge. When an atom loses or gains electron, they become ion, right? But what are compound ions? So ions which are formed from a group of bonded atoms are called compound ions. For example, if I write sulfate ion, SO4 2 minus, this is known as sulfate ion. So this is an ion which is formed from sulfur and oxygen. If I talk about OH minus ion, it is hydroxide ion. It is also my compound ion because there are now two elements involved in it, oxygen and hydrogen. If I write PO4 3 minus, it is known as phosphate ion. This is also an example of compound ion. Is it clear what are compound ions?
Yes.
These are my compound ions like F minus, Na plus. These are simple ions. No compound. Write it down.
I've written it down.
So the next example is your sodium carbonate. How to write down? If I ask you to write down the formula of sodium carbonate, so what is the step to write down the formula? First of all, write down the cationic part, sodium. It's simple. Carbonate. Carbonate is CO3. Okay. Then in the second step, you have to write down the valency. Write what I am writing. In the first step, write symbol. In the second step, write down the valency. Valency of sodium is 1. You need to remember the valencies. Valency of carbonate is 2. Now in the third part, just use the crisscross method and the formula is Na2CO3. For calcium nitrate, write down the symbol for calcium. Symbol for nitrate is NO3. Now write down the valency. Valency of calcium is, it belongs to group 2. So its valency, it should be 2. Valency of nitrate is 1. Use the crisscross method and the formula is CaNO32. So these 3 steps you have to follow whenever you are writing any chemical formula. Is it clear?
Yes.
Write it down.
Should I write the examples as well?
Yes, pardon?
Should I write the examples as well?
You have to write examples only. How to write down the formula of sodium carbonate. How to write down the formula of calcium nitrate. These are examples only. Homework question is that work out the formula for each compound, copper 2 chloride, iron 3 oxide, and you have to write down the formula for sodium sulfate, potassium hydroxide, and silver nitrate. If there's any problem, we will discuss it in the next class. The homework. You have to try it at you, right?